Hey, this is Mrs. Gregg. Let's talk about how to read a solubility curve. A solubility curve tells you how many grams of solute will dissolve in 100 grams of water at a particular temperature. And generally what we see with most solids, and here's an example of a couple of them, is that with an increase in temperature as you heat up the water, we're going to be able to get more of that solid to dissolve. We see an increase in solubility. That's for most solids. There are a couple of oddballs on here. So for example, ammonia has a different slope there. Let's look at the ammonia. Ammonia's here. It has a downward slope. It doesn't have an upward slope. But that means that ammonia is actually less soluble as you see an increase in temperature. Ammonia is a gas at these temperatures. So as you're increasing the temperature of that solution, the gas is actually going to escape. It's going to bubble right out. So that's why we see that ammonia has less solubility with increasing temperatures. And that's generally true for most gases. Okay, let's talk about what this curve means. Yes, use this one as an example. What that tells you along this curve is that's the maximum amount of solute that you can dissolve at that temperature in 100 grams of water. So let's say at 40 degrees, the most amount of sodium nitrate I'd be able to get to dissolve in 100 grams of water would be 105 grams of sodium nitrate in 100 grams of water. That's the solubility at 40 degrees C. If I try to add any more than 105 grams, let's say this is my cup over here, got some water in it, and I've added sodium nitrate, and let's say that's 105 grams of sodium nitrate. If I try to add any more at 40 degrees C, it's just going to sink to the bottom and quit dissolving. Because my solution is saturated, that means it can't hold any more solute. And each of these lines tells you when a solution is saturated at a particular temperature. Okay, we can talk about undersaturated. If a solution is undersaturated, that means you'd be able to get a little bit more to dissolve in it. Okay, so if we go back and we use that sodium nitrate line as an example, anything under that curve, that's where the solution is unsaturated. We can add more solute and get it to dissolve. That's unsaturated. Okay, if you're up above the curve, if you're in this region, that means that as you add more solute, you can't get it to dissolve anymore, and it's just going to sink to the bottom of the cup and stay solid. So that is here. We're saturated, we just can't get any more to dissolve. Okay, there is a special case. It's called supersaturated solutions. With a supersaturated solution, if you heat it up, you would be able to get that extra little bit that wasn't dissolved, you'd be able to get it to dissolve because we see this general trend of an increase in solubility with increasing temperatures. So I apply that heat and I'm able to get this that was sitting down on the bottom of my cup to dissolve. It goes into solution in this warm solution. And then if I remove the heat and I let that solution cool down, that solute will stay dissolved, and we call that a supersaturated solution. All right, so that's some terminology that you need. Okay, let's look at the problems that you have for homework. First one asks about at 10 degrees C, which one has the least solubility? So I go to 10 degrees and I start heading up here. The first line that I encounter, that's the one that has the least solubility at 10 degrees C. So that potassium chlorate, that's the least soluble. If you want to find the second least soluble, keep going up, and where you intersect, it would be that one. Okay, so that's how you figure out who's soluble at what temperature. Okay, next question you have, number 2, says, which of the salts has the greatest increase in solubility as the temperature increases between 30 and 60 degrees? So we are looking at this range. you're looking for who has the steepest curve. There's the steepest slope. Potassium nitrate has the steepest slope. That's the one that is most soluble. Okay, your next question asks which one is least affected by temperature, and which one is the solubility least affected by temperature. And there you're looking for generally a flat slope, something that looks horizontal. So I'll let you figure that one out. On number 3 is who has the flat slope. That's going to be the one that's least affected by a change in temperature. Okay, on to number 4. There's a problem with number 4. It switches between sodium nitrate and sodium chloride. It should just be sodium nitrate the whole way. So we're dealing with this curve. It says at 20 degrees C, we have 100 grams dissolved. There we are. And 100 milliliters of water. Knowing the density of water is 1 gram per milliliter. So if you're told that you have 100 milliliters of water, that means that you have 100 grams of water. Okay, so we are here with the amount of solute. That means since we're up above the curve, that means that we have added more solute than will dissolve, and you've got some sitting on the bottom of the cup. So we're in a situation like this. Some of it's sitting on the bottom of the cup. Okay, so then it says how many grams of sodium nitrate must be added to saturate the solution at 50 degrees C. I'm going to come along at 50, figure out where it intersects that line, and that's about 105. Looks to be, yep, 105 grams of sodium nitrate, 115. 115 grams of sodium nitrate. Let's go at that again. At 50 degrees C, that's what the water can hold. Okay, and right now we have 110, right now we have 100 grams. So you subtract and you find that we could add 15 grams more. Okay, so if we were to draw a line to show that, it would go from here, we have 100 grams, and we're going to add 15 grams more. And that will put us at being saturated. Okay, I hope that helps. That was a little long. Definitely ask me questions if you get stuck. Ask me on Schoology. Talk to you later.